In this video, we're going to perform binary classification on the Pima Indian dataset. But before we do that, let's quickly look at this library or package that is used to offer us these features for performing machine learning tasks in Python. This library is called scikit-learn, abbreviated as sklearn. This is a very popular library for machine learning because it provides a wide range of algorithms or classifier for both classification, or rather for classification, regression, clustering, dimensionality reduction. You can do some data pre-processing from this model selection module, feature extraction, and lastly, also we can do model evaluation to assess the performance of a model. Again, sklearn is kind of built on NumPy and matplotlib, very powerful libraries. Again, also it interfaces very well with other deep learning frameworks like TensorFlow and PyTorch. So what makes sklearn very popular is because of its simplicity, efficiency, and versatility. Again, it's a great choice for beginners levels up to expert. You can click on this link and just takes you to the official website on sklearn, and you can see it supports all these different models. These are actually the classifier, right? So logistic regression, perceptron, trees, and so on and so forth. So having said that, our first classifier algorithms we're going to look at for this binary classifications are logistic regression. Now, logistics regression is used for binary classification problem. I kind of just use a logistic function. So this is what we call the sigmoid function. I'm not going to get into the mathematics of this, but this is how it looks like. Again, here, the mathematical explanation, it just kind of use the odds ratio. Odds ratio is nothing but probability of success divided by probability of failure. Again, here it looks like an S-curve. Again, it just tries to find the transform the output from a linear combination of features so that we have a range from 0 to 1. Again, those data points can fall between those ranges. Okay, so to do this, we're gonna import 3 important libraries here. So the first one here, just say from this library called sklearn, import this module called model selection. So this model selection allows us to perform data splitting. So we're going to use the train test split. This allows us to split our Pima Indian dataset into train and test data. A second package you are saying from linear model, as you can see, import logistic regression. So logistic regression is from this linear model. So you click on that, you can see at the top here, it's coming from this library module, and this is the function. Okay, so from here again, we see that we are also importing the module metrics. This is what will help us to assess the performance of our model based on accuracy, precision, recall, and F1 score. So this is based on the confusion matrix. Remember, we started with the confusion matrix, and from this 4 squares, we can compute the accuracy, we can compute the recall, specificity, precision, and whatnot. Okay, so essentially this is what will help us do that. So the first thing we do here is to import our data set, right, and call it df. The next thing is to use this function. We want to split our data, our df here. So essentially here, so this will be our x. Okay, so we drop the outcome, the target variable. So the remaining 8 columns will be the x. Then here we're saying for a y, we call that outcome, the last column for our class. Then the test size here just essentially says here, we want to do 80-20 split, meaning 80% will be our training data, 20% will be our holdout data for test data. Okay, so this is what this line is saying. And then the next thing, we create an instance of our classifier. Remember, we kind of imported this logistic regression function. So now we need to create an instance of this and call it LR model. Okay. So once we've instantiated that, we can now call the fit method and pass our training data and our test data. Okay. So what this fit function does, it kind of just transforms, this is where the magic happens, right? You're training your data to learn the relationships. Okay, so once it learns the relationship between your predictor variables and your outcome variable, we can now use it to predict on our test data. Remember this 20%, the test size here. So one thing I just need to mention, so once this is split, okay, it's automatically apportioned to, this is the test data for Y, and this is the test data for X test. So this is the 20%. Then the X train here will be the training data, 80%. The Y train here will be the training data, but 80% for the target variable. So we, after training our model, we now use the predict function here, okay, to see how well, to see whether it can predict some of our holdout data on X test, right, the 20%. And we call this YPRED. Then to evaluate our model, we just call these measures, right? So we essentially, we're just calculating, computing the accuracy here. TP, for example, just how does it perform? How accurately does it predict both TP and TN out of all our predictions? So again, here for accuracy here, we just pass the accuracy score, we pass Y test and YPRED. So the difference between the predicted here and our actual values, right? And then we save this as accuracy, just for brevity, precision, recall, and F1. So here we're just recording the differences between the prediction and the ground truth, or the actual values, right? Then now we can print these results. So essentially here we're just using formatted string. We can actually score. So here, first of all, we just want to find the accuracy here. So this is the accuracy. So I'm just gonna, I've already run this. So we have the accuracy, precision, recall, and F1. We can see here the accuracy is 7.34, precision 0.6, 4.89. That's almost like 49%. F1 score is 53%. So again, we can create the confusion matrix by getting from this module, metrics, and we can import the classification report. This classification report will create for us this kind of table, right? So to do this, we're just gonna print classification underscore report, and then we pass our Y test and YPRED. Again, here the actual values and the predicted values, and then we'll summarize for us this table. Okay, now let's summarize this table and see what happens here. So precision here essentially just says, out of all the patients from our model, predicted will get diabetes, only 60% actually did. And we can see here, remember the outcome here was 0 for those who didn't have diabetes and 1 for those who had diabetes. So we're interested in this. Okay, then recall, again here we're saying about 50% or 49% of those patients were predicted correctly. Okay, so this model doesn't do very well. Okay, then F1 scores just the harmonic mean between precision and recall, given that by this formula, 2 times, and then that divided by 0.6 plus 49. That's what we get here, 0.54. And then the support here just means that, the value simply means here the patients that belong to the outcome 0 that didn't get diabetes, and those who were predicted to have gotten diabetes, or rather 49 patients did not get diabetes. So this is how to kind of just, sort of interpret that. Okay. So next we're going to look at decision trees.